right, so our topic today is on computational advertising, and we're also going to talk about how you can perform computational advertising, perform the analysis of a graph in a parallel environment. So we really have two topics today. And so this is basically the agenda. We'll go over the foundations that you'll need to understand the algorithms that'll be applied, some background on the actual problem that we're trying to solve, business problem, the algorithms themselves, and then how it gets applied in a parallel environment, specifically MapReduce. So the first part is just a brief overview of the difference between an online and an offline algorithm. So an offline algorithm is something that's performed over the static data. So in other words, you have your entire data set prior to actually starting the computation. And so it allows you to be able to optimize everything because you know all of your inputs in advance. So the contrast to this is the online algorithm where you're trying to make decisions based on incomplete information. So it's typically related to streaming data, such as an actual online data, say like a search query or something like that, where you only have partial data and then there's still future data that is an unknown element that you have to take into consideration. So because of that, because you're making decisions on partial information, your online algorithms will always be less optimal than your offline algorithms. So you're basically making irrevocable decisions at each point without having the complete picture of what you're looking at. And so this is typically, the simplest example of this is in the form of a bipartite graph, which is basically a graph just connecting two different types of nodes together. And so the example that we have here is if we have a set of nodes of TAs and then a set of nodes of professors, and the goal is to match a professor with a TA. Of course, you have constraints on whether or not the TA actually has some functional knowledge of whatever the professor is teaching. So not every TA could possibly be compatible with that particular professor, which is why you don't necessarily have potential paths between each TA and each professor. So those are your constraints there. So given that information, does anybody have any ideas of some of the potential ways that we could capture the connections between the TAs and the professors? Anyone? Bueller? Okay, so one example would be that you could connect 1 to A, and then you could connect 2 to B, you could connect 3 to D. You can't, once you have one connection, you can't reuse the connection. So another path might be 1 to C, 2 can only connect to B, 3 to D. Or you could do, say, 1 to C, 3 to B, and then 4 to A. So you have a few different paths there that you could follow. Oh, okay. And so the other function, or the other kind of term that we'll talk about is cardinality. And so cardinality of a graph is the number of total matches that can be made from that graph. So in this case, you can see the dark colored lines are going to be the matches that we made between our TAs and our professors. So in this case, the cardinality of this graph is 3. So a perfect match would obviously be where we have every TA matched with every professor, and that is also the maximum matching. So it's the maximum is going to be the largest number that you could possibly make. So going back to the difference between the offline and the online, if we have in the offline version, we know all the possible paths, so you can compute that perfect or that maximum matching, not necessarily the perfect, but the maximum matching, because you know all your possible inputs prior. As opposed to the offline, you don't know what's going to be coming up next. So you just have to make best guesses based on the available information as new streaming data is coming in.
Can you ask your question?
I I had a question on there.
Right, okay. You can just ask another one.
Okay, so, yeah, I can just use this one, that's fine. Yeah, that's fine, I can use this one. So, what would we say is the cardinality of this graph right here?
Cardinality of which graph again?
The cardinality of this graph right here.